Now to the questions. Question 1. You are to state the boiling point of the sample X you are provided with, and the answer depends on the temperatures you took. Question 2. From the boiling point you obtained, you are to identify sample X. Now, from what you people did, we discovered that you were busy copying yourself, and some of you were leaving biochemistry lab to come to chemistry lab, and some will go from chemistry lab to the biochemistry lab to see what they are getting. You are forgetting something. You were not given the same organic substance. For example, in chemistry lab, you were given N-hexane. So the sample X is N-hexane, and so the boiling point is meant to be around 68 degrees centigrade. Whereas those in biochemistry lab were given ethanol with boiling point around 78.37 degrees centigrade. But you were going up and down, copying yourself, and that is why many of you actually miss the questions. So please, henceforth, whenever you are given samples, ensure you do your work. I've always been saying this and I'll keep saying it. Trying to copy somebody does not make you to be original. So, in that, the samples provided is thus stated with their temperatures. Now let's look at question 3. What happens to the boiling point of water? 1. At a height of about 10,000 feet without pressure cooker. And 2. At that same height of about 10,000 feet, but in a pressure cooker. And you are to state the reason for your answers. Now, with a pressure cooker, without a pressure cooker, one thing stands out. Same height, high altitude, around 10,000 feet higher above the sea level. So, at such heights, you should know that there will be decrease in atmospheric pressure. The atmospheric pressure will decrease because of the height. So generally, boiling point of water decreases with altitude due to the decrease in atmospheric pressure. So, to answer question A, at a height of about 10,000 feet, without the use of a pressure cooker, the boiling point will decrease. Now, what is expected if the boiling point decreases is that water boils at a faster rate, but at a lower temperature. Now, let me use this to explain. When you are at home and maybe you are trying to cook your rice and you are watching a movie and you are trying to I don't want to miss this movie or this rice. You now lower the gas. Your rice will keep cooking, but you will be rest assured that it's not likely to get burnt. Why? You have reduced the temperature. Even though the rice is boiling, you can actually see that the rice is boiling. But because the temperature at which your rice is cooking is lower, the real cooking will not happen faster. Instead, it will be slower, but it will keep boiling. So, 3 things you should take note to answer question A. At a height of about 10,000 feet, without the use of pressure cooker, there will be decrease in atmospheric pressure, and this will lead to decrease in boiling point. But this will lead to boiling of your water faster at a lower temperature. But the one thing you should take note of this is that when you are cooking in that condition, your cooking will take a longer time and your food may not be cooked well. Why? Food needs to be cooked at the maximum temperature expected. So when you do your cooking at a lower temperature, you may end up eating a not well cooked food, and that may give us disturbances in the body. So you need to cook your food well. So you should expect that at high altitude, you need something to help you out because of all these factors we have noticed. Now, further explanation, as you can see on the screen, at 10,000 feet above sea level, the boiling point of water is 193.2 Fahrenheit, which is 89.6 degrees centigrade. You can see the temperature is lower, but the cooking will not be properly done. So your water will boil faster because the boiling point of water have decreased, but your cooking may not be done, may not be carried out very well. So the boiling point of water at different other altitude is as shown on the screen. You can see them, 500 feet and so on and so forth. So let's fast forward to where we have 10,000 feet. 10,000 feet is ticked and is typed in red. 10,000 feet, you have 89.5 degrees Celsius. Lower boiling point, faster boiling, lower pressure, but bad cooking. All right. Now, what are the reasons? Because we are asked to state the reason. What are the reasons your water boils faster at a height of 10,000 feet? As I've explained before, it is due to the lower atmospheric pressure. At higher elevations, pressure drops, which means there's less air pushing down on your water. 2. Lower boiling point. Because the boiling points have reduced, it means your water will boil at a lower temperature. It won't reach the normal 100 degrees centigrade before it will start boiling. Okay. Number 3, water boils faster. So I've explained that. Now, question 2 of that's question 3, part 2 of the question 3. What happens to water that is being boiled in a pressure cooker at 10,000 feet above sea level? What happens in that place is that 1, there is lower atmospheric pressure, just like you have lower atmospheric pressure without pressure cooker. There is still lower atmospheric pressure even with a pressure cooker around you because of the drop. Because of the higher altitude you have gone to, the pressure will drop generally. Now, at higher elevations, atmospheric pressure is lower. But what happens to the boiling point? Inside a pressure cooker, the build of a pressure cooker is such that an increased pressure is operative inside a pressure cooker. So the use of a pressure cooker will help you to combat lower atmospheric pressure that is outside. So the pressure cooker will increase your boiling time, meaning that the boiling point will increase. The boiling point increases, take note, with the use of a pressure cooker. Your boiling point increases as the pressure inside the cooker increases, and then water boils slower but with increased temperature. Even though the boiling point increased, the water, when you are saying water boils slower, but note that it is with increased temperature. So even though it is boiling slower, because the temperature is very hot, it will reach cooking on time, and then you'll be able to cook your food very well. So, summarily, the boiling point increases, the time you will take to reach the temperature increases, but the cooking is better because your food is actually getting enough heat. And all this that happens within the pressure cooker outside the pressure cooker follows the ideal gas law, which states that when pressure increases, temperature increases. But when pressure drops, temperature drops. And all this happens at constant volume. So I will advise you to watch this video that I've sent the link here. Please watch the video. You'll be able to understand more about what happens at higher altitude. God bless you. See you in the experiment 3 recording.